name is Irina. I am a developer over at Scripto. We write scripting software and we do a lot of work. Well, all of our work is in JavaScript, so Node and client-side JavaScript. And we do a lot of work with operational transforms. So I write Node and I do operational transforms. Cool. So Scripto. And today I would like to talk about compression. And when I start off kind of this talk, I go into kind of a bit of research phase where I try to figure out what it is that I want to do. And I was reading this paper on what it is like to minify and compress your code. And kind of this is what one of the first lines of the paper was this, which I thought was kind of really cute. But that brought me to think about the fact that, you know, most of our work has changed in a way we'd handle JavaScript. And we create a lot of JavaScript traffic. And I kind of wanted to figure out, because every time we go through creating software nowadays, we go through minifying and compressing our code before we serve it up to the client. And so I wanted to look into that portion of it, because by being able to kind of work with that particular part of traffic and being able to compress and minify the code, we can save up to 50%. Kind of from the same paper, same takeaway. So what does compression look like? This is taken straight up from like my bundle code that I'm working on right now. You've got some gzip going on, you're working with a minified version of code, you want to log some errors, you want to write it to a file, you want to serve it up afterwards. Maybe you're doing that with Nginx, maybe you're doing that straight up with your code. Either or, you're compressing. But let's actually, what I want to focus on during this part of the code is HTTP compression. And in fact, I want to talk about zlib and I want to talk about gzip. So HTTP compression. So what it looks like is you got an HTML file. You gzip that HTML file. And what it looks like in the end is something like this. So if you've gzipped the file previously, you look at it, it's a bunch of mumbo jumbo, but what you're essentially ending up is a much smaller file. Pretty cool, pretty basic, but let's actually dig into it. So in regards to specifically HTTP compression, what we have is we have a client and a server set up. What client does is it says, I want to work with some encoding, and these are the encodings I can work with. They could, nowadays, they're either gzip, deflate, or broadly. These are the ones that are accepted by all your major standard browsers. Broadly was just accepted into Edge, I think 2 months ago or something like that. So you're able to work with those. And what the server then does and says, OK, the content and encoding I'm going to send to you, and what's most convenient to me based on what you're saying you can accept, is broadly. So I'm going to choose and send you over some broadly. And this is what it looks like if you wanted to look at it inside your browser, right? So you're looking into the accept encoding. These are your request parameters. And what you get back is your response parameters, which say, OK, the content encoding you're sending back is gzip. Cool. But kind of before we get into gzip broadly or anything of that sort, let's talk about deflate, because deflate is what is the stem of kind of these compression algorithms. And what deflate is made up of is two different algorithms. One's called the Huffman, and the other one's LZ77. So let's kind of dig into what Huffman algorithm does, because that's kind of what all those will come down to. So essentially what you do is you deal with streams. You've got a data stream that comes through. It's got a bunch of values. We want to parse through that data stream. And what Huffman coding does is it first generates a frequency table. So given that particular data stream, we're then able to see how many values and what kind of values get repeated and how many times. So we can see that C gets repeated once, given a very simplified data stream. A gets repeated 3 times, so on and so forth. And then what you end up doing is creating a probability table. And that probability table is based on the total values within that stream. As you go on, increase. And then what you end up doing is building up a Huffman tree. And they're called trees because you kind of build out this little tree as you go up and go through your values in the stream. So what you start off with is the fact that you've got all these values, and they have probabilities, and these are the number of times they occur. And then you build your tree up. So A and C all together come up, and then you get that top portion off as you build up. And you get the values, and you got the frequency from previous frequency tables, and you got the probability, and it's a tree because each individual stem is a leaf. So the right-hand side starts off always being a 0, and the left-hand side starts out as being a 1, and you keep going down the tree. So our right-hand branch can't go any further, it always stays 0, but we prepend a 0 to the right-hand side of the bottom branch and a 1 to the left-hand side of the branch. And your bottom value is the code that comes up at the end of the tree. So that's Huffman encoding. And what LZ77 is this other algorithm that creates a length and distance pairs, and this is how it works. So you also have a data stream, so everything, as you guessed, is streams. But you create like a window. You go through a window through the stream, and the window is made up of 2 parts. One is a search buffer, and the other one's a look-ahead buffer. You're currently in the look-ahead portion of the buffer, and you go back and look through the search buffer as you move on. And that window moves as you go through the stream. And the distance portion of that is, given a particular value, you want to find out where was it before that you've seen it. And your search pointer stays in your search buffer, and then you're able to see whether or not, what's the distance between the previous time you've experienced this particular portion of your code. The length is the number of characters that get repeated. So again, you have your search buffer, and you look back in your search buffer and see how many characters get repeated, and that would be your length. And the entire thing is made up of length and distance pairs, basically those 2 values we just talked about. So that's DEFLATE. And DEFLATE's like the basics that come back into working with PNGs, working with the basic zip, working with gzip. Everything comes back down to DEFLATE. And they all take down as kind of a similar thing. And what DEFLATE does is that there's other parts of it, is that you have made up of 3 different bits. And the first bit is letting you know whether or not there is any more things to come in the stream. So back in that data stream, we can find out whether or not it's ended or not. And then you get your raw data, and you get your static Huffman blocks in your second bit. And the third bit gives the dynamic Huffman blocks and the table that, the frequency table that we generate in the first place. Cool. And so the compression is basically made up of those same pointers that are LZ77, and the weighted symbols that Huffman blocks come back. Cool. And so gzip, what gzip does is that it's a combination of what DEFLATE is, but the node interpretation, because we're talking about JavaScript and we're talking about node, the node's interpolation is a zlib. So you require zlib, and you're able to kind of get that in. And what zlib does is that it allows you to have more processing power and more memory use, more control over those 2 items than gzip, or just using DEFLATE from then on. And then you can create better trade-offs, and you're able to kind of, I guess, make different presets as to how more compressed you want something. So if you go with a compression level 9, it's going to take a lot longer for it to get processed, but it'll be a lot more compressed than a compression level 1. And like I said before, because if we're dealing with Node, we're able to require zlib and be able to use that. So given all those, I kind of wanted to show you an example as to what these things actually look like. So normally I would kind of live code this entire thing, but we have 20 minutes, so I'm going to show you what it actually looks like, and then we'll see kind of the size of something like that, and what's the difference between some of these things. Essentially, what we're doing is we're going to create a server. And what that server is going to do is it's going to listen for some of the things that our client is requiring. And then based on the things that we're passing in to our server, we're going to compress that data. So I'm using a couple of things. I'll get into broadly in a bit. But I'm using pump, which is an awesome library to work with streams. It handles your errors, unlike streams are a little bit broken, so it doesn't quite do the error handling that pump provides. We're working on it. And we're going to use zlib, which is just Node's zlib implementation. But let's go through this. So what we want is based on the server that we create, we want to go through request and response, and we want to grab the headers that we pass on. What we do then is we create a read stream from the source. And that read stream is is basically just a plain HTML file, and that HTML file looks like this. Just a plain old, nothing interesting. And then what we want to do is look at that, those accept headers and see whether or not something like deflate comes in. And once we get through this, we will respond back and we'll pump down the source. And zlib's got an implementation for create deflate, and it's got an implementation from create gzip. So we'll work with those two. Awesome. So let's look at kind of what this returns to us. So what we want is make sure that this server is running. And then what we want to look at is just a simple kind of what it looks like on 8080. So simple index.html looks nice and long and nice and long. But we can see that we've got no encoding is passed, and it's just a connection. But what we want is then kind of see what it looks like with deflate, for example, without the word count. So word count, this is a compressed version. Kind of cool. Gzip's going to look exactly the same, just compressed content. But let's actually look at the difference in word count, or the kind of an easy way to measure what looks like what with word count. So I'm just going to pipe it into WEC. So let's look at the most basic of these without header, just curl. So that comes back with 8,772. Let's look at what it looks like with deflate. Deflate comes back with 2047. And if we look at gzip, comes back with 2059. So a little bit smaller than deflate. Sure. So regular, deflate, gzip. So gzip's pretty much the same. OK. So that's what I wanted to show you. So broadly, it's been accepted in the most major browsers as an encoding format. That's why I kind of wanted to take a look at it. CDCH doesn't get used anymore. In fact, Chrome discontinued it, so that's done. Broadly is a much better interpretation of that. So what's Broadly? Broadly has been specifically put together to work with HTTP compression. So it comes with a bunch of cool things that you can work with within HTTP compression. Start off, again, kind of still the basics of deflate. Start off with a stream. You got some literals that you can't compress, and you still go on with length distance pairs. And that comes back to being a single block within deflate. And what Broadly does is that you actually work with commands rather than static blocks. So your actual insert literals are things that come back from dictionaries that are a lot more dynamic than they are in deflate, because deflate comes back with more static dictionaries. But a dictionary that comes with Broadly is specifically made for HTML terms. So you'll have things like doc type and head and div that are already kind of come up for you. You don't have to recompress them, so it's easier. But the only thing with that is just because you have such a larger static dictionary, you actually go a lot slower in terms of the way you put that together. But there's actually a really neat implementation in Node. I can't pronounce that, but it's Broadly backwards, which is cool. And it's pretty well put together, and I really quite like it. And it's interesting to kind of play around in comparison to what gzip and deflate gives you, because it's definitely a lot smaller. So with Broadly, what you have is also the same thing, and I've used pump, even though, yeah, so there is a streams implementation for it. So you just require the library, and compressed stream will return a stream that you can then pump into pump, or just your regular stream. And then what you end up getting is a much smaller compressed size, so it's like 1669 in comparison to 2059. The only thing is, like, this is a pretty small HTML file, it just takes like a lot longer. There's a bunch of other implementations for kind of specifically for HTTP stuff.